Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. Now you can see it's a different type of video today in that you're not seeing my hands on a bench, you're seeing my hands on a desktop. However, to be fair, that desktop does look an awful lot like my bench, so perhaps you can emulate the experience at home. But I wanted to show you something I've been up to because I really have been getting back into 3D printing in a big way. With the purchase of an Anycubic, and you can see I'm even printing something right now, so that's probably the noise you hear in the background, and I'm printing out this thing you see on the screen that I designed in Fusion, which is the cover for a Nintendo Famicom. You can see in my Autodesk Fusion a load of different designs. Some of them I put on my Thingiverse, some of them never make it that far, but I definitely go through them. But I'm going to start a new design because I wanted to design today. There we go, so we have a fresh thing. And the thing I wanted to do, I wanted to design something and I was going to show you the whole thing, how I do it. So I install Fusion. That's the first thing you need to do if you haven't got one. But if you do have some of the free CAD and those things, they do work as well. You just got to get used to the user interface, whichever you want. And the thing I want to design though is a little gadget for holding screws. So we've designed lots of things and printed, this isn't my design actually, but I've printed it, like various things for holes like that, and I've got a nice one over there that I'll show you later that I designed. But I never designed anything that holds the little screws. Now I think that would be useful, and I think the criteria is it should be a small little thing that's quick and easy to print. And you can put your little screws in it, and maybe we can make them stackable or interlocking. That could be cute, but that's a secondary aim for me today. So the first things first, I'm going to create a box, and it's going to be nice and simple. Now if you don't have one, get one, a metal ruler, and keep that on your person at all times because you're going to need to refer to it. So I reckon something like a 15 centimeters by 10 centimeters could be a cute shape. Let's just do that. So I'm going to place a corner randomly here, and then I'm going to say 15 centimeters by, what did I say, 10 centimeters. And normally I'd work in millimeters, but today we're chucking in the centimeters. Now thickness, because we don't want it too deep. You don't have to put your fingers right in, so it's quite shallow. I reckon no more than 20 mil deep, so that's what we're going to go for, 20 mil deep. And what you can do, before you confirm that, you can just rotate this around and eyeball it, see if that looks about right. And you go, yeah, that does look about right. I mean, that's absolutely fine, isn't it? It's just basically a block. So let's rotate it back round to the top. So that's looking down. You're looking down in this little thing, and you're going to want these little pots. Now, I think it needs at least 6 pots. Like we said, it's 15. So I don't know, maybe 3. No, 4. 4 centimeter diameter should work, shouldn't it? 40 millimeters for those working in proper units. So what we do for that now, by the way, there is something you can do, and that's go on Autodesk Tinkercad, which is almost Fusion but for free. They seem to offer some sort of fusion-y type thing, 40 millimeters, for kids. My kids were on it the other day because they used to using Scratch and the like, and that's something that you could do. If you went on there, I think it looks like it's almost Fusion 360, but not, if you get me. Right, so now looking at the thickness of this, so remember it's 20 millimeters thick, so if we make it, I think 1 millimeter thick base is a bit too shallow. I think we're gonna, sorry, too thin. I think we're gonna want 2 millimeters to set it's a little bit rigid. So you don't want to poke your component in and just rip straight through the bottom of this. So that'd be a bad news. And you can see actually I've set it as a cut, but right now I don't want to do that. So I'm just going to create it as a new body, and I'll show you why later. That's fine. So just say new body, and that's what that looks like. And just so that we don't lose track of it, I'm actually just going to pull it out the top a little bit. Yes, I just want to make sure that I've done this right. So you see I've basically got a cylinder sticking out the top. And if I try to right, so you've got to be super careful. So what I've actually done there is I ended up joining the two things. So at the moment you can see it's an independent shape. In fact, look, I'm just going to swing it off there. That's fine. And what I'm then going to do, I'm going to say, okay, you can go there. I'm going to extrude it out the top. So I want it to be a bit taller. And then I'm going to have a look from the top again, and I'm going to decide where I'm going to actually start putting these things. Now, if you use maths, which clearly I haven't because it doesn't look like I'm going to fit as many as I wanted in here, you can actually obviously get your ruler, and there are actually functions in here like this pattern, rectangular pattern, that would actually arrange them for you. I mean, if you want to do that, you can. In fact, let's just do that. You can actually just select the object. No, I want to select the body. Select your body all over my body. And then directions. And I'm not quite sure on this, how this directions thing works. It's always a bit weird, but okay. Quantity. Okay, so you can see how it's kind of going. It's giving you this little thing, which is fine. But in that direction, I only want 2, basically, and the gap between them. Actually, see how you work it out. I think if we put in the diameter plus space, so 50, yeah, you see, 45, 42. That's probably more like it. And then in the other direction, let's see, 42. 5 there. Oh my gosh. So you can see why I normally don't mess around with these type of things. I just can't be bothered. I lose the will to live sometimes. And I don't entirely know how it works. Well, we're getting there. We're getting there. But for something like this, we're not talking precision engineering. It's normally good enough. So I think that is probably pretty good. But obviously when we create this, our block of stuff is not really adequate anymore. But what you can do, of course, is just delete it. Just get rid of it. If you can figure out how to select the thing. You can delete it from up here normally. Yes, right. So let's start again in a way. We're going to just drop this. I like to move things onto the 0, 0 if you can find it. And that is down here. You can see the 0 there. We'll make it more or less the center. And it's handy to do that because when you go to print your thing later, your Cura or whatever slicing software is going to expect it to have the correct coordinate system. And if you don't, it's going to make a mess of it. Right, let's just choose. Let's just go like that. Again, we're doing it all from eye, really. Boom. Boom, shake, shake, shake that room. Look at that, that's cute. And we wanted it 20 mil, if you remember. And you see you can have all these different things. You can have your intersects, joins and all that. But just go straight just for new body. And we've made a Lego. We've made a Lego brick, but that's fine. Okay, good. So now we've got the basics of shapes. And then we want to go to combine. And then you're going to choose the target, which is our big block. And then we're going to say we want to cut from that target the tools. And these will be the tools, these little guys here. If you can select them through there. And you say boom, shake, shake, shake the room. And there you got your little tray. But there's a lot of material there, obviously. You can still, it's quite chunky. So next thing you want to do is maybe a fillet. And what I like to do is I like to go around and choose all the corners. If you remember when I made the retro joystick thing, we did the same process really. Oh, look at that. That looks actually quite good. Looks like something you could keep eggs in. And you can just play with that. I mean, you can see it's not perfect because we didn't actually mathematically work out how we want that radius to be, but it doesn't matter. That looks actually pretty good. Now, the problem you have if you've got components and you shove them in these things, like if you've got especially little surface mount resistors and whatnot, they tend to get stuck in these corners. So I think we want to do the same trick here, really. And I'm going to go through each one like so. Oh, yeah, look at that. Okay. That would be extra chunky. Ooh. You see there's error. It's like giving it a mathematical error. I actually kind of like it though. Not obviously because that's totally dished, but a little bit, right? I mean that looks to me it's only like slightly flat on the bottom, but you could be able to just get your finger in there and scoop it. Scoop it up. I mean, let's have a quick look at the front. I mean, that's half it. It's about a centimetre worth of scoopage in there, so I think we definitely want that. And while we're at it, let's go to town on all these. This is going to be the ultimate in egg storage. Oh. I'm getting all sorts of errors here because because of the way at it. It's not able to quite apply it in a sensible way. Bad edge blend geometry. Okay, let's do it here. So we're at 22mm. Let's just manually do it 3mm. Look at that. That looks sick, doesn't it? 1.5. Yeah, you go. That's more like it. 1mm. Well, I think that's right. So that's basically what we want on that. So it's not so harsh. And then we can go around, do the same here again. Oh my word! Look at that. That looks crazy good. Again, sometimes it's best just to put it in manually. I want to just turn it around and look at it at a few different angles. I mean, that's okay, but it looked quite fun, didn't it, when you went a bit too much? And you've got plenty of sidewall. I mean, this would be still really strong at that, but I think we can split the difference a little bit. Yeah, I think that's okay. That's fine. And then if you wanted to, you could put something in these holes. And I like the idea of something to hold little things like your brushes or your twizzlers. So I think we should do a few little holes here. We'll do that in the same way as before by placing a... well, actually, you do have a feature here to make holes. I was going to do a cylinder, but you can actually make a hole. I'm not really... They're okay. I'm not massively comfortable with them because it's kind of made for drills, but you can do it. And you can see that's like blitzed right through. So you have to specify the depth of your hole. Again, imagine you're drilling something with a drill bit, so you're going to have 18mm and your diameter, I think I'm going to put it more like 10, but I am aware things like these brushes are super fat. You're looking at 12 to 13mm, but if you make these holes 12 to 13, they won't be so useful for the other stuff. So I'm going to go 13. Let's call it that. Again, I'm never really quite sure on the datum for drill holes. They always seem to be quite free-handed. Oh, and you can place multiple. Interesting. Ah. Oh. I wish I didn't do that now. Okay, let's get that in there. It's fine, just do it. And I've said okay, and now we've got a hole. So if you're lucky, it will remember the same settings for each hole, which it seems to have done, so that's okay. And we're going to move on again. Let's get one more hole in there. Yes, 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 yes. Now, what do you think? Should we put some smaller holes here, just in case you've got some smaller stuff, like your tweezers? You know, you might just shove the end of your tweezer in the hole. I think that's a good idea. I'm reckoning more like probably like an 8mm. So we're going to go for 8mm. I'm just going to place that dead center. Get another hole. You've got lots of them. We could just put them all over the shop. And every hole you put down, if you think about it, that's something you don't have to print. So it's going to speed your print up a bit. And this is going to be a nice easy print because you're basically going to print it straight off. That hole wasn't very good, by the way. I didn't put it in a very good place. But I think there's a slight issue in when I placed the original cylinders, but it's okay. Again, stuff like this, often you won't see it in the print because you've got to look at the tolerances here. You're often working at much tighter tolerances within your CAD package than your printer is capable of, so don't sweat it. Because you see here you've got lots of room around the hole, whereas on the top ones you get a lot less room. It's fine. And here's the last one. So inclined, I would think about adding words. You can add your logo, and even your logo will be 3D printed nicely. I've seen it where somebody's like put their logo on the side and the 3D printer's been able to handle that nicely. So I think that is looking quite good. So what I do then is I will save that, and you've got to call it something. I'm going to call it component draw. No, that's not what it is. A component tray. Now, if you remember though, we did say it would be nice if these could slot together or do something fancy. I'm probably not going to bother with it too much, but just to show you how I would drop an 8mm magnet down these and put some filler material in there, bit hot glue, and then put an 8mm bit of metal on here, or a ball bearing. So then they would stack magnetically. So you could do that. So the next stage now then for me is to export this, and I'll normally just export it as an STL file. And I'm going to just sit and wait. Now once this STL file has downloaded though, I am going to put it onto Thingiverse. So you will be able to download this yourself and print it out. And while that's happening, I'm going to take my bit of Cura here, and I'm going to go to new project. It's my slicer, and depending on your slicer you're going to have different options. In fact, I just realized I have 2 copies open for no good reason at all. And there it is, component tray is just turned up, and there you go, look at that. I think that looks quite snazzy. It's about the right size. Of course you can slice it. Now there is a trick I have as well when you're in your 10 hours. Yeah, okay. I think we can print this in draft mode. We definitely don't need it. 5 hours, that's getting better. Now let's turn off the support. I don't think we need any supports at all. 5 hours 31. So that's pretty much the same time. So one of the tricks I do have in Cura, and you can see it there actually, the reason supports didn't make any difference is because it's not using any, is when you're in Cura you can do some tricks. Like if you wanted to have a double one of this, you could actually place 2 down, and then if you go to arrange all, you'll see how it will, in fact that's how it wants to arrange them. You can see it's actually left them with a bit of a gap, because of course it doesn't want them to mostly when you're printing things like this you don't want them to actually join. But what you can do is you can actually move it together, and you can see Cura does this thing. If you've got the right angle you'll see it more than others, but you'll see it, you see them starting to eat into each other like that. Once you're starting to eat into each other, you definitely, when you print them, will come out as a single piece. So if you change the angle like here, you can see that they're just starting to merge. When you print it out, it will come out as a double tray, which you may or may not want. Anywho, instead of that though, what I'm going to do is I'm going to say arrange all models, and then I'm going to, and that slice button, oh, I don't know if you can see it, is down here. and it says 5 hours 31. So when I was doing that talking about the hours, it's down here behind me where that button is. And then I just say print with because Octoprint is busy, unable to start a new job, but I'm going to say queue the job anyway. And that's going to pop it down here. And you can see my Octoprint might look a little bit different than your Octoprint, and that's because I've got a load of customizations on it. And actually, while the system is messing around and uploading to Octoprint, you can see it says storing data on Octoprint. I can show you what plugins I actually have. So I've got the dashboard plugin, I've got the heater timeout plugin, which I think you should definitely have. I've got the print time genius plugin, which is really good at accurately calculating the print time. It's much better than the standard Octoprint timer. And then I've got Themify, and that's set to discorded, so that's giving me this nice grayscale. And then you can just jump in, of course, and then do all your widgets. And you can see here it says AC component tray. Actually, what do I always say it puts AC in front of everything? I've never queried that. AutoCAD, right? Okay. AC component tray, and I think it's still doing its calculations, but once it's done its calculations, you'll be able to click the little down arrow here and it'll tell you how much filament it's going to use, how long it's going to take, when did you last print it. And what's really nice, if you set up a little Octoprint server like this, it stores all of your previous jobs. So what you can do is, when you've got good jobs here, like for example this Famicom cover manufactured adjusted G-code, right? All these things, RetroNet V4 print in place. I just keep them there. I don't delete them because they're great. And so then I don't even need to load up Cura next time I want to print it. I just can log into Octoprint from my phone anywhere I am and just say go. And you can see here you've got the graph showing you the temperature of the print bed and your print head, which is super useful. So you can just monitor that. You can see it's nice and steady. No worries there. And then of course if you've got the camera set up, you can see it's still in the process of actually printing that previous item. And there are the G-codes right there. And then I do have something that's rather cute here, which is time-lapse. And down here I actually have time-lapse video, because it has a camera on there. It takes a time-lapse video, and you can download that after. So if you've got one of those interesting prints and you put the camera in the right place, you can see that thing where it looks like it's growing out of your printer bed. So I think that's what we've got to do. I've got to wait now another fair old few minutes, and then once those few minutes, like here we go, look, 20 minutes left, and then I can start the print on this one. Finally, the previous print has cleared, as you can see, and I've actually sent now the component tray job to the printer, and it's taking its time because what it does, first it heats the bed. So you can see here it has a target of 60 degrees C, currently at 53, and then it's going to heat the actual extruder, so my mind went, and that'll be about 200 degrees C. And then after those two things are completed, it'll just start that print. And then a whopping 6 hours and 34 minutes later, this tray will be ready. And it's currently 6:45 in the evening, so that's a fair old wait. So I'm hoping to finish this video in the morning, and that will be Saturday morning. Might be time just to get it out there so you to watch before lunchtime. So let's see what happens to this print. Hello, I'm back, and it is 1:45 in the morning, a little bit late, hence the dressing gown. And I will show you what came out of the printer. But before I do that, I want to show you a couple of things I printed. I mentioned them earlier in the video. So this, if you look on my Thingiverse page, is a pen holder. Very lightweight, very thin, quick pen holder I made. But I did combine 3 of them on Cura, as mentioned before, to make a triple version. And that's holding a lot of my tools and junk right now, which I'm very pleased with. And this isn't my design, but something I was really quite pleased to be able to put together, because I actually have the parts, which is to make a miniature extractor fan. So if you look at my previous videos, maybe 2 or 3 ago, I had a big desktop extractor fan, which I automated. And this is a very mini version, but you know, I can turn it on. You can see it works there quite nicely. And you can actually remove the charcoal filter, which is quite cool. Got my little back office badge. So yeah, great. When you have a 3D printer, you can do anything you like. So that is the end result of what we've just done. Now, I did notice quite early on, early in the night actually, when we started this, that I did have a bit of an adhesion problem. I think I mentioned that. And I just let it go though, because it's really not a problem for this dimensionally, but I could have stopped that and corrected it. I didn't. So that's on me, guys. That's why we've got a little lump here. But I can just take my little tool here, my reamer, and I'll just go through. Get rid of that so you don't have any horrible extraneous piece of plastic there. You can see it's a little bit furry inside. Remember, we did print this as a draft print, so we would have to go through now and just normally just rubbing that with your fingers enough just to get rid of that little bit of fur where you have the filament. I think it's called stringing. So if you have your nozzle, sometimes if you have your nozzle particularly too hot for your particular filament, you can get that as well quite heavily, where it's basically leaking out the nozzle, and as the nozzle's moving it's dragging that little bit with it, but it's easily rectified, something like this. So I'm going to simulate though that's in use. By the way, it does look like an amazing egg thing. I think it will hold several eggs for you to paint them. Certainly be able to hold your tools like that, your little reamers and pens temporarily. Maybe not that one, that's nice and fat. Let's have another test of a pen. There you go. Tweezers, the small hole with the tweezers, so useful for that. But the main use case, of course, was for small bits. Mainly screws, I think. A lot of the time you've got screws on the go. Not really assembled surface mount stuff myself in a while, to be honest with you. That's really where it might help. Now the thing with surface mount stuff, a bit of firm get that out. You need to be able to get at it, and I think you won't really have too much trouble. I think it could be a little bit shallower, because the angle I sit, I could have a surface mount component here, and the angle on my eye, I can't quite see it, so that might be a little bit annoying, but I think that's okay. And just to show you something else, actually, the 3D printed thing that's quite cute is this device. So you've seen component leg benders on this channel before, and in fact I'm going to print another one because I've misplaced the one I had. But this one is for bending component legs en masse. So you put your actual tape of components in here, and it's very difficult to do with just two because they're not still on the tape. Just a bit of tape on one end. And you can fill this whole thing and put, I think it's 7 in there, and then you just bring this down and you just crunch it through, and you can see actually from the top that you've got your 2 there, and pop it out, nicely bent. Look at that, that's handy if you're doing a lot of through hole stuff. But I know I'm rambling there, so hopefully that's been interesting to you to see the process of making a tool thing. And I think I'm going to be using this in future videos. Look out for it. And structurally, by the way, it's insanely heavy duty. I mean, this is well over engineered. You can't get any kind of twist or torque on it. I will just show you one last thing though before I sign off. Something I've bought a while ago. I don't know where it was from. Maybe Wilco or Robert Dyer, somewhere like that. And this stick 'em up non-slip rug gripper, and it's just a tape. It's a single-sided tape, but it's actually got a very rubbery. It's got covered in these rubbery blobs. Look at these. See these rubbery blobs right there. And I find it very handy for certain things. So you've seen it on the bottom of this desktop fan. So this fan, actually, I've put a lot of I super glued washers on it to give it more weight because it was very top heavy with that fan. But I've put that on there, so that when you put it on there, you can see it moves the board. It's very grippy. Sometimes when you print stuff like this, you can see it is kind of slippery, and it's kind of hard to rough this up because if you try to rub it up too much, it kind of goes a bit weird and furry because you start melting and it's not good finish. So yeah, you can sometimes just stick some of that on there and you'll give it a nice bit of adhesion. So thanks you very much for joining this little ramble through the whole 3D printing design and printing process. But yeah, please comment down below about your journey in 3D printing, and if your workflow is similar to mine. Again, mine's not a formal one, I just made it up. It seems to work for me, but I'd love to hear about yours if yours is better, more efficient. Yeah, please ping that down. As ever, like, share, subscribe, and thank you very much for watching.